0-day brief.
So imagine downloading a brand new piece of software.
Yeah.
Okay.
And it's got this gold standard cryptographically verified seal of absolute security on it.
Right. The system is basically telling you it's perfectly safe, pristine, nobody's touched it.
Exactly. So you go ahead and install it,
Yeah.
only to realize that the security seal itself is literally what just delivered a highly sophisticated virus into your network.
Yeah, wow. It completely inverts the entire concept of trust, doesn't it?
Yeah.
I mean, you aren't just being tricked by a fake, you are being compromised by the very system that's designed to protect you.
And that is the exact nightmare we are exploring in today's deep dive. So our mission today is to trace the arc of this threat actor known as TeamPCP.
Yeah, they are a fascinating group.
Very. We've got this chilling security briefing in front of us that chronicles what researchers are calling the 4 waves of Shai-Hulud. And we're going to map out how this single group essentially industrialized supply chain attacks. Like, they started out launching these crude, blunt force digital worms, right? And then within months, they evolved to shipping malware that carried perfectly valid security signatures.
Which is just wild.
Okay, let's unpack this.
Right.
Because I think the most important thing for you to grasp right up front is that this wasn't, 4 random unconnected hacks.
No, not at all.
It was one set of hands. They were running a full software development cycle, iterating and improving, exactly like a legitimate tech company would, but, for a massive cyber attack.
Yeah, and I think that highlights a fundamental reality about modern cyber threats. The most dangerous threat actors out there do not get caught.
Right.
They get better, they learn from their failures, and more importantly, they learn from our defenses. What we see throughout this briefing is, well, the core tension of the whole incident.
Yep.
TeamPCP didn't just find a single vulnerability and hit it repeatedly until it got patched. They systematically dismantled deeper and deeper layers of the open source trust model. Every time the industry plugged a hole, TeamPCP was already anticipating the fix and basically subverting the patch itself.
But to really appreciate the sophisticated climax of this whole campaign, we have to start at the beginning.
Yeah, we do.
Because they did not start out as these criminal masterminds. Wave 1 kicked off in September 2025. The briefing labels this the experiment, and honestly, it was basically a digital smash and grab. They used a tool called TruffleHog. Now, if you work in software, you probably know TruffleHog is a defensive tool, right? Security teams use it to scan their own code bases to see if, any developers accidentally left passwords, API keys, or secrets lying around in the open.
Right, exactly. It's a diagnostic tool. But TeamPCP completely flipped it. They used TruffleHog offensively to scour the internet and harvest compromised published tokens for NPM.
And for anyone listening who might not be deep in the code every day, NPM is essentially this massive central library where millions of JavaScript developers download pre-written code packages to, build their websites and apps.
Yeah. So if you have a developer's publish token...
You basically have the keys to their specific section of that library. You can upload updates in their name.
Precisely. And TeamPCP used those stolen tokens to create the very first self-propagating NPM worm.
Wow.
The logic was brilliantly simple, yet honestly pretty crude. Steal a token, use it to publish a malicious update to every single package that the victim developer controls. Then, when other developers inevitably download those infected packages for their own projects, the worm wakes up, scans their machines for their NPM tokens, steals them, and the cycle repeats. Exponential spread.
So it hit about 500 packages in 48 hours.
Yeah, fast burn.
But I was reading the reaction from the security community at the time, and they kind of just shrugged it off.
Yeah.
The general consensus seemed to be, some script kiddie got clever with TruffleHog. It's a one-off anomaly. We revoked the tokens, problem solved.
Right.
Nobody seemed to connect the dots to what this group was actually practicing for.
And that complacency completely set the stage for Wave 2, which hit just a few weeks later in November 2025. This is where things escalated to what the briefing categorizes as industrial scale. TeamPCP infected 492 packages.
Which sounds like a similar number to Wave 1.
It does, but this time those specific packages were getting 132 million monthly downloads.
Insane.
The blast radius was astronomical, and they achieved that scale by weaponizing something called pre-install hooks.
Okay, I want to make sure we really nail down why this is such a big deal. Normally, if I download a piece of bad software, the virus doesn't actually trigger until I click on it, or in a developer's case, until they actively write the code to import and run that package in their app.
Yeah, exactly.
But a pre-install hook changes the rules entirely.
It absolutely does. A pre-install hook is a script embedded within the package itself that is instructed to execute automatically the exact millisecond you tell your computer to install the package.
Oh, wow.
It happens completely in the background, before any human eyes can inspect the code, before you even open your code editor. It is pure zero-click execution.
Right. It's like walking up to a store, pulling the handle on the front door, and getting robbed before you even cross the threshold. You didn't buy anything. You just touched the door, and boom, your wallet is gone.
That is a great way to put it.
And if that wasn't bad enough, the payload they attached to this zero-click trigger was incredibly aggressive. If the worm tried to steal your tokens and failed, say, your corporate firewall blocked the outbound connection, it had a scorched earth fallback mechanism.
Oh yeah, the wipe.
It would completely wipe out the developer's home directory on their local machine. There's a post-mortem in our sources from a company called Trigger.dev, and the way they describe the damage reads like an absolute horror story. Years of local files, configurations, personal data, just vaporized in a second.
Yeah, what's fascinating here is the rapid evolution of their strategy. I mean, think about the leap they just made. Wave 1 proved that the developer trust model could be broken using stolen keys. Wave 2 proved they didn't even need developers to intentionally use their code.
Right.
The attack surface suddenly exploded from, packages you actively implement in your project to literally any package you simply type install for. They turned the fundamental mechanism of downloading code into a loaded weapon.
And once they knew they could achieve that kind of massive indiscriminate scale, the briefing shifts. TeamPCP didn't want to just be a loud, destructive wrecking ball anymore. They realized that quietly sitting inside a network is way more valuable than wiping a hard drive. Which brings us to Wave 3, the precision strike in April 2026. This time, they narrowed their focus, specifically targeting the SAP and intercom ecosystems. But what really caught my attention was the persistence mechanisms. Like the incredibly specific ways they made sure their malware stayed alive on your machine, even if you realized you were infected and tried to delete it.
This is where the technical specificity of their operation really shines. Normally, if a developer realizes they've accidentally installed a poisoned NPM package, the fix is pretty straightforward. You just delete the no modules folder where all those packages live. The threat is gone.
Right, you just crash it.
But TeamPCP anticipated this. So they didn't hide the core malware in the package folder. They wrote it into a file called .claude/settings.json, which is the core configuration file for Claude Code AI agents. They modified the settings so that every single time a developer launched their AI coding assistant to help them work, the AI tool itself silently re-executed the malware.
That is wild. I mean, if you're a developer who just installed a brand new AI coding assistant to speed up your workflow, that very tool is being weaponized to quietly resurrect a virus on your machine every single morning.
Yeah, it is a brilliant abuse of trust. But they built in redundancies too. They also injected their code into .vscode/tasks.json. So simply opening the project folder in VS Code, the most popular text editor in the world, triggered the worm.
Wow.
And for Mac users, they went a step further, installing a system-level macOS launch agent called com.user.ja-tokenmonitor.plist. By embedding it at the operating system level, it meant that even if you completely wiped your project files and rebooted your entire computer, the worm survived. It just kept waking up with your Mac, harvesting your GitHub tokens in the background indefinitely.
Now, there is a very specific, fascinating detail in the source material for Wave 3 that we need to point out here. The malware actually checked a setting on the infected machine called the lang environment variable. This variable essentially tells the computer what language the user speaks. The researchers note that if the machine's language matched ru_ru, which is the Russian locale, the worm would just cleanly exit.
Interesting.
It wouldn't install the persistence hooks. It wouldn't steal any tokens. The source document labels this behavior as political signaling by the attacker. And we're obviously just looking at the technical behavior outlined in the report here, impartial to the politics. But it adds an incredibly interesting layer to how these groups operate and subtly signal their affiliations in the wild.
It certainly does. And returning to their technical expansion, Wave 3 is also where we see them pull off a massive cross-ecosystem pivot. They realized that staying inside the JavaScript world was just too limiting. So they jumped to PyPI, which is the equivalent package registry for the Python programming language. Then they jumped to the GitHub container registry, targeting Docker images.
They're just branching out everywhere.
Exactly. And they stopped just looking for NPM tokens. They started hunting for multi-cloud credentials, grabbing authentication tokens for AWS, Azure, and penetrating local HashiCorp vaults.
Okay, let's pause on HashiCorp vaults for a second, because that is a massive escalation. Think of a vault as the digital Fort Knox for a company. It's where you store the master passwords to your most sensitive infrastructure. If they are breaching the vault, they aren't just messing around in your web app anymore. They have the keys to your entire corporate kingdom.
Right. And if we connect this to the bigger picture, the deepest insight of Wave 3 is that TeamPCP was perfectly mirroring the tech industry itself. Legitimate developers were rapidly adopting AI coding agents to write code faster. TeamPCP immediately targeted AI coding agents. Organizations were migrating to complex multi-cloud architectures to scale their businesses. TeamPCP expanded their net to hunt multi-cloud credentials. They weren't sitting in a dark room guessing what developers might be doing. They were reading the exact same industry blogs, tracking the same trends, and weaponizing those massive shifts in real time.
Which sets up this incredibly dark paradox for Wave 4. If TeamPCP is mirroring the tech industry so closely, what happens when the industry decides to implement strict cryptographic security signatures to stop groups exactly like TeamPCP?
Right.
Well, they don't retreat. They don't try to go around the signatures. They attack the signatures themselves. This brings us to the absolute climax of the briefing, May 11th, 2026. The researchers call this the illusion of trust. There was a frantic 6-minute window where 373 malicious versions of packages suddenly flooded the NPM registry. They heavily targeted a very popular critical ecosystem called @Tanstack, which handles nearly 13 million downloads every week. They also hit @Mistrala, UiPath, and bizarrely, a whole cluster of aviation data packages. But here's the most shocking revelation in the entire document. The malicious @Tanstack packages carried perfectly valid SLSA build level 3 provenance.
Which, we should clarify for everyone, is supposed to be the absolute gold standard of supply chain security. It is cryptographic, mathematical proof that a piece of software was built securely on a trusted server and has not been tampered with by a third party.
Right, so I'm reading this and thinking, wait, how is that physically possible? How can a highly malicious virus have a perfectly mathematically valid security signature? Is this like a criminal somehow forging a fake passport that looks real? Or is this the government accidentally issuing a totally real passport to a known criminal?
It is absolutely the latter. The signatures were 100% real because the build process was real. There is a verification system called SigStore that checks these signatures, and SigStore looked at the malware and said, yes, this mathematically checks out. TeamPCP didn't forge the cryptographic attestations. They hijacked Tanstack's actual official GitHub Actions builder.
Wait, really? The actual build?
The very infrastructure that the legitimate Tanstack developers used to compile and sign their safe code was compromised. This raises an important question about how our industry defines security. When the factory itself is compromised, that gold standard seal of approval doesn't protect you at all. It actually becomes camouflage. It makes the malware look completely trustworthy to every automated security scanner in the world.
Okay, so we've established that the builder was hijacked, but we really need to break down how they actually pulled off a heist like this, because attacking a highly secure, automated build pipeline sounds like trying to break into a bank vault through the ventilation shaft. But the briefing outlines the anatomy of this hijack as a highly coordinated 3-step chain. And step 1 starts with a deceptive code submission. The briefing calls it the Pune request.
Yes, the initial infiltration. They started by quietly forking the Tanstack router repository, creating their own copy of the code, but they deliberately chose an account name designed to blend into the background noise of search results so nobody would look twice.
Sneaky.
Very. Then they submitted a pull request, a formal proposal to merge their changes into the official Tanstack code. To make it look legitimate, they faked a commit signature so it appeared to come from the Anthropic Claude GitHub app, an automated AI bot. And they gave the request an incredibly boring, mundane titled WIP Simplify History Build.
Now, if I'm understanding the vulnerability they exploited here, this pull_request_target configuration, it's like Tanstack basically gave the keys to the castle to anyone who submitted a suggestion. The setting tells the server, hey, go ahead and run this stranger's incoming code to test it and treat it with the exact same high-level security privileges as our core developers, right?
That is precisely the fatal flaw. Security researchers have been screaming from the rooftops about the pull_request_target pattern for years. GitHub's own official documentation explicitly warns developers in bold text never to use it with untrusted code because it allows external code to execute within your secure environment. But, for whatever reason, Tanstack's configuration had that vulnerability exposed.
So step 1 gets their code executing inside Tanstack's server. But just getting the code to run for a few seconds isn't enough. They needed their malware to survive and infect the official release process, which means they had to somehow sneak their malware into the project's permanent memory. This is step 2, cache poisoning. How exactly does that mechanism work?
Well, when massive software projects build their code, they don't want to download thousands of underlying dependency files from scratch every single time. It takes way too long. So they cache them. They temporarily save those files in a storage area. Because TeamPCP's initial malicious code was running with high privileges, it reached into that temporary storage and injected poisoned files into the project's cache.
Oh, I see.
So later, when TanStack's legitimate developers logged on and ran their official, highly secure release workflow to publish a real update, their system unwittingly pulled those poisoned files straight from the cache. Now, the attacker's code is firmly embedded inside the highly secure release environment.
And that leads to step 3, which is where things get truly sci-fi. It's honestly the most chilling technical detail in the whole griefing memory scraping.
Yes. Once they were running inside that secure release environment, they didn't go looking through the hard drive for passwords. They ran a Python script that read the server's live memory directly. It targeted a system path called /proc/pid/mem. It literally scanned the active electrical brain of the GitHub Actions worker process while it was running.
I love this detail because it completely bypasses traditional security. Think of a computer's hard drive like a heavily guarded lock safe. You can't just walk up and open it. But live memory scraping, that proc-mem path, that's like standing behind the company's accountant looking over their shoulder while they have the safe open on their desk.
Yeah, exactly.
They didn't need to break the lock. They just watched the system think.
That is a perfect analogy. And because they were looking at the live memory, they were able to extract things that are specifically designed to be unstealable. They searched for JSON objects flagged as secrets. They managed to extract highly privileged OIDC tokens.
So for the listener, OIDC or OpenID Connect tokens are meant to be the ultimate secure handshake. They are incredibly short-lived identity-based credentials. They're designed to be generated, used for a few minutes, and then vanish without ever being written down on a hard drive. But because the system physically has to hold that token in its active memory for a split second to use it, TeamPCP was there, waiting to scrape it.
Exactly right. They extracted OIDC tokens, NPM publishing tokens, and cloud credentials straight out of the machine's active thought process.
Okay, here's where it gets really interesting. Once they had those ultimate keys to the kingdom, they shipped their payload. And it was massive, a 2.3 megabyte file of deeply obfuscated, messy JavaScript. But when security researchers painstakingly deobfuscated it to see how it worked, they uncovered some incredibly quirky, almost theatrical details.
The personality of the threat actor really bleeds through the code here. TeamPCP set up dead drops hidden locations to store the data they were stealing, and they were entirely Dune-themed.
Dune-themed.
Yeah. They created hidden code branches designed to mimic an automated security tool called Dependabot, but they named the branches things like Fremen, Sandworm, and Melange, all heavy references to Frank Herbert's sci-fi universe. They even left marker repositories public on the internet with descriptions stating, "A mini Shai-Hulud has appeared." Shai-Hulud being the giant sandworms from the novels. They were practically leaving a cinematic calling card.
And it wasn't just sci-fi jokes either. Their communication strategy was incredibly sophisticated. They didn't just have their malware call home to a single evil server that a security team could easily blacklist. They used a decentralized session P2P protocol for their command and control network.
Right. By using a peer-to-peer encrypted messenger network, the malware's communication just looked like standard randomized encrypted traffic bouncing around the internet. There was no central server to block, making it an absolute nightmare for network defenders to track or shut down.
So what does this all mean for you, the listener? Whether you are a developer, a security analyst, or just someone who relies on software to run your life, which is all of us. Why should you care about cache poisoning and memory scraping? Because this deep dive fundamentally changes the math. It shows that supply chain security isn't just about making sure you vet the specific libraries you download anymore. It's about acknowledging that highly sophisticated, extremely patient threat actors are running iterative, months-long development cycles against the very pipelines we rely on to build our digital world.
And they are only getting bolder. The most unsettling detail in the entire document comes right at the end, where TeamPCP decides to step into the light. The researchers document a post on Breach Forums, a notorious darknet marketplace where TeamPCP announced a public partnership with the Vect ransomware group.
Unbelievable.
They aren't hiding in the shadows anymore. They are actively building a public brand. They have a business model. They are monetizing their access and building infrastructure for whatever comes next.
Which leaves us with a pretty heavy realization to chew on. TeamPCP just spent 8 months systematically proving that they will eagerly follow the tech industry wherever it goes. When we relied on static NPM tokens, they found a way to steal them. When we pivoted to using AI coding agents for efficiency, they built malware that hid inside the AI. When we rolled out cryptographic provenance to mathematically prove our code was safe, they hijacked the exact machine making the proof, weaponizing the very concept of trust itself. So as the industry scrambles right now, spending millions of dollars to build some new, supposedly unhackable trust mechanism to replace the one that just got dismantled, what exactly makes us think TeamPCP won't simply use that brand new system as the camouflage for Wave 5?
Thank you for listening to Zero Day Brief.